All right, guys, we have got the test review for Chapter 9. These problems should look very familiar to you because we have done problems like this for many weeks now. But I'm just going to recap and very briefly go through each of the types of problems you're going to do. First one, starting with, is a triangle. I am going to always, as I've been telling you for many weeks, start with writing the formula. And please make sure that you show me the numbers that you're plugging in. The base is 12, the height is 4. Don't forget to divide by 2. And yeah, make sure that you have this for a triangle written correctly on your note card as I'm going through this. I know you have a note card that you've made or that you've used many times already. Let's see, what is 12 times 4 divided by 2? We get 24. Okay. There's the triangle. Rectangle, you know how to do this. A equals BH. The base is 12. The height is 8. And when you do 12 times 8, we get 96. So 2 formulas down, several more for the shapes to go. What about the trapezoid? We're going to take the first base and the second base times the height and divide it by 2. And the first base is 19. The bottom one. The second base is 11, the top one. The height is 10, and I'm going to divide by 2. And so when I take 19 plus 11, I get 30. 19 plus 11, I'm going to multiply by 10, and I'm going to not forget to divide by 2 because it's part of the formula, 150. Can you double check that you have the trapezoid formula correct on your note card? Look at this very carefully. Yes, it is a plus sign here. And remember that the two bases, I'm going to highlight this, those are the sides that are parallel. So the sides that look like train tracks, okay? The square is the same as the rectangle, so I will skip that one. The parallelogram is also the same as the rectangle, but you're using the two sides that form the right angle, so make sure you're okay with that. And then the rhombus, I do want to talk about that one because it seems like we still sometimes get a little bit confused on the formula for the rhombus. The D1 diagonal, that refers to from one corner to the next corner. So what do you do with both of those 7s? You add them together to get 14. The other diagonal goes from this corner to this corner. That's literally what the word diagonal means. So what do we do with both of those 5s? We add them and get 10 and divide by 2. And so when I take 14 times 10 and I divide it by 2, I get 70. And double check your note card and make sure that you have a times symbol there for the two diagonals. And if you need to make a note to yourself that one of the diagonals goes from one corner to the other. I tell you that I see very frequently, sometimes people only use the 7 and the 5 in the formula, and that is not correct. Use the entire diagonal. Area of a regular hexagon. This should be on your note card. It's probably the last formula that you have on your note card, and the formula should look like this. 6s squared radical 3 over 4. And that is when you see literally these words, regular hexagon, this is the formula for it. And yeah, it's kind of weird, but it gives us the side length of 5, and that's the only number that you need for the formula, and it goes right here. So I'm going to put 6 times 5, don't forget the square, radical 3 over 4. And how do we type this into the calculator? 6 times, we take 6 times, you can take 5 and use the caret button for the exponent of 2. You can take 5 times 5 because that's what 5 squared means. And then don't forget where the radical 3 is. You're hitting the blue button and then the x squared button to find that radical 3. Yeah, you can type 5 times 5, or when you're typing the 5 squared, you can use the 5 squared button. You can write 5 caret 2. The little caret is the arrow symbol that indicates exponent. Make sure that you check in with one of us if you don't know how to type this. But this is the numerator, and then I can't forget to divide this thing by 4 at the end. So I get 64.95, or rounding it to 65. Okay, so there's the area of the regular hexagon. What have I missed? Let me just remind you how to do these problems. For number 8, there is a rectangle. So I'm going to start with the formula. But in this case, the area is one of the things that we're given. So this number goes here. And the base is 22, which goes here. So I'm plugging in those numbers. You guys, start with a formula. And most of the time, on the first page of the problems, I gave you the base and the height. You just plugged them in, right? But can you figure out what to do if I give you the area? That goes in for the A. So I'm going to put 374 equals, the base is 22, the height I don't know, so I'm going to leave it as an h. And then you know how to solve this in algebra. This is how you got to geometry, as you passed algebra. We need to get h by itself, so we are going to divide both sides by 22. So when I take 374 and I divide it by 22, I end up with h equals 17. Cool. We're going to do the same thing for the triangle problem. I'm going to take A equals BH divided by 2. Check that on your note card. It is there. The area is 30. I don't know the base, but I do know that the height is 6. So I'm going to plug in those numbers. So area is 30. The base I don't know. I'm leaving it as a B because look, it's a B right here. I have to figure it out. The height I said was 6. And can't forget to divide by 2. Here, because we have a divided by 2 in this formula, and in this part we did not have a divide by 2, I'm going to get rid of the 2 first. What I'm going to do is multiply both sides by 2. When I do that, the 2's cancel on this side. That's exactly why I did that. 30 times 2 is 60, and I have 6 times b on this side. b6 is the same as 6b. Now I know what to do. I'm going to divide both sides by 6, and I get b equals 10, and that is super. Number 10 should look familiar. It's a perimeter of a square is 12. You know what perimeter means, okay? I'm going to draw a square. This side is all equal. And if the perimeter is 12, remember, that does not mean that this side is, oops, dang it. Where's my, this is, keep hitting the wrong thing. I'm really sorry. Okay, that does not mean that this side is 12. That is absolutely not correct. That means this plus this plus this plus this all adds up to 12. So how are we going to figure out what each side is? Well, 12 divided by 4 is 3. That means this is 3, this is 3, this is 3, this is 3. And that gives me a perimeter of 12. Now the question asks me to calculate the area of the square, and the area of the square is base times height, just like a rectangle. And it looks like, you guys, the base is 3 and the height is 3. So I'm going to put 3 times 3, which is 9. Careful on that problem, okay? I'm going to do one of each of these types, and then I'm going to be finished. Calculate the sum of the interior angles. You have a formula on your note card for sum interior, and I think it probably looks like this. N minus 2 times 180. And what is the n again? Oh, 1, 2, 3, 4, 5, 6, 7, 8. 8 sides. I'm plugging in 8 for n. And 8 minus 2 is 6. And I'm going to multiply that by 180. And I got 1080, and that is how you do the sum of the interior. Remember, you guys, that you have to look for keywords in the wording of the question. Sum, find it on your note card. Interior, find it on your note card, because all the formulas kind of look very similar. So just be careful that you are doing the same thing. Sum interior for a hexagon, that would be the same way I did for number 11. It's just that a hexagon means that there are 6 sides instead of 8, so you're plugging in 6 for n. 1 interior, I have a formula for that, and I have to look really carefully at the word 1 and interior. And so my formula for 1 interior is n minus 2 times 180 divided by n. Okay, and for a regular triangle, triangle has 3 sides. So I am plugging in 3 minus 2 times 180 divided by 3. 3 minus 2 is 1 times 180 divided by 3 gives you 60. Okay, let's see. Sum exterior. You have a formula for that on your note card. Sum exterior. And it's not even a formula. It is 360. Boom. Make sure that you got that on your note card. Sum exterior, no matter how many sides, it doesn't matter. It could be a triangle, a heptagon, octagon, a rectangle, not rectangle, square, pentagon, hexagon. Any of those is always going to be 360. Okay. Last formula I'm going to review would be 1 exterior angle. You have a formula for that, and it is a little bit different than all of the other ones. It starts with 360 and it divides by n. Make sure you've got that on your note card. Pentagon means n equals 5, so I am plugging in 5 right there. 360 divided by 5. What is that in my calculator? 360 divided by 5, 72. Thanks for watching. Thanks for playing. Don't lose that note card. I want to make sure that we're okay with problems like number 16, number 17. If you have room on your note card, then you might want to copy down these exact problems, because look at this thing. It's a little bit different. Why is it different? It's because I have all of the exterior angles here, and I'm looking for one of the exterior angles. In this case, all of the angles are on the outside of this four-sided figure, which is a quadrilateral. And so what I need to first do is figure out what they all add up to. The sum of all the exterior angles is always 360, okay? But I know this one and this one and this one, and I have to figure out what is angle 1, okay? If I know what they all add up to, then I think you know what to do after that. We're going to subtract 105, we're going to subtract 99, and we're going to subtract 112. 360 minus 105 minus 99 minus 112. I am left over with 44. Okay, I started with 360 because these are all exterior angles. Okay, look at the picture and notice that they are exterior. Therefore, use the exterior formula, which is not even a formula. Okay, let's see. This one's weird because this one is interior. Do you notice how all of these angles are on the inside of the what's the shape called? 1, 2, 3, 4, 5 pentagon. Okay, so I need to figure out what they all add up to. And I have a formula, sum, but this time they are interior. And there's an actual formula for it. It's not 360. Remember, it's n minus 2 times 180. And since there's 5 sides, I'm going to do 5 minus 2 times 180. 5 minus 2 is 3 times 180, which gives me 540. That means that when there are 5 sides, all of the interior angles, because these angles are all on the inside of the shape, all of the interior angles add up to 540. But I'm going to do the same exact thing now. I'm going to subtract 121 and 119 and 80 and 142. And I'm going to end up with, bear with me while I type this into my calculator real quick, 80, 142, and I got 78. Excellent. If you want to copy those problems down on your note card, then do it. Thanks for watching. Let's crush this test.